Good morning, children. We proceed on to miscellaneous problems of chapter 7. Question number 1. A manufacturer of metal pistons finds that on the average 12% of his pistons are rejected. So rejected probability, let us call small p, that is 12%, or I will say 12 by 100, which is 0.12. Because they are of oversize or undersize. We need to find the probability that a batch of 10 pistons. So 10 pistons claim us to write n equals 10. Not more than 2 rejects. So when my question is probability of not more than 2 tells me it is x less than or equal to 2, or I will say x is equal to 0 plus x is equal to 1 plus x is equal to 2. So we need to write what is x. So x represents number that is rejected. So number of rejects we shall call as x. As we remember the formula for binomial distribution, it is NCX P power x Q power n minus x. As I know P, Q equals 1 minus P, or 1 minus 0.12, that is 0.88. As we substitute it, my question is x less than or equal to 2. X is equal to 0. Wherever x comes, I will put 0. N is 10, P is 0.12, Q is 0.88. NCX 10C0, P power x 0.12 power 0, Q power n minus x 0.88 power 10 minus 0, that is 10. Then we have to put x is equal to 1. 10C1, 0.12 power 1, 0.88 power 10 minus 1, that is 9. Substitute x is equal to 2. 10C2, 0.12 power 2, 0.88 power 10 minus 2, that is 8. As I simplify, in all the terms, see which is common. 0.88, the whole power 10, 9, 8. So power 8 is common. What is left out? 10C0, the value is 1. Any number power 0 is again 1. 0.88, 10, but I have taken 8. So 10 minus 8, 2 is left out. 10C1, 10. 0.12 power 1, 0.12. From 0.88 power 9, I have taken power 8 as common. So power 1 is left out. Plus 10C2, 10 into 9 by 1 into 2. 0.12 the whole square. Use your calculator. It is 0.0144. 0.88 power 8 is already taken out. So the calculation stops with this. As I simplify further, 0.88 whole power 8 is 0.3596 into 0.88 the whole square 0.7744 plus 10 into 0.12 into 0.88. It is 1.056 plus if I cancel and multiply, I get 0.648. As we add it all, it is 0.3596 into 2.4784 or 0.8912. We have completed A part, which is not more than 2 rejects. Now we proceed on to B part. My question is at least 2 rejects. What do you mean by the word at least 2? It is equal to or more than 2. At least 2 tells me equal or more than 2. That is 1 minus what I don't want. Because more than 2 tells me 2 to 10 I need to calculate. 2 to 10 calculation is difficult. Instead, greater than or equal to 2, we rewrite x less than 2. 1 minus x less than 2 or 1 minus less than 2 tells me either x value 0 or x value 1. Already we have calculated x value 0. My answer is 0.88 power 10 plus p of x is equal to 1. This answer 10c1 is 10, 0.12, 0.88 the whole power 9. As I simplify these two, we get 0.88 power 9 common. I am left with 0.88 plus 10 into 0.12 is 1.2. As we add these two and multiply with this, we get 1 minus 0.6582 or my answer is 0.3418. Let us quickly glance through the problem. As we read it, 12% of his pistons are rejected. So number that is rejected, let us consider as x. What percentage? We call as probability. 12 by 100, that is 0.12. Once I know PQ is 1 minus P, subtract and write it. A batch of 10 pistons. So N equals 10. My question is not more than 2 rejects. As we know, some are rejected. It is binomial with parameters N and P. Not more than 2 tells me the rejects are less than or equal to 2. That is x taking the value 0, 1, 2. As I substitute in binomial distribution formula and simplify, we arrive at 0.8912. Second part, at least 2 rejects. X greater than or equal to 2. At least 2 tells us greater than or equal to 2. That is 1 minus probability of x less than 2. Greater than or equal to 2 tells me 2 to 10 I want to calculate, which is difficult. So what I don't want? Below 2 I don't want. So below 2 is 0 and 1. What I don't want? Subtract from 1. These two we have already calculated here. Just to substitute. Use the calculator, simplify, subtract from 1, we arrive at 0.3418. Question number 2. Hospital records show that of patients suffering from a certain disease, 75% die of it. So the question mentions 75% die. That implies the remaining, that is 25% recover. 75% die tells us 25% recover. What is the probability that of 6 randomly selected patients? So 6 represents N. N equals 6. 4 will recover. The last line tells us about success rate. So 4 will recover tells me recover percentage is P. And the remaining I call Q. This number I call N. So I know what is NPQ. So P is 25% tells me 0.25. Q is 75% tells me 0.75. So every time you read the problem, understand that the last line, the last statement, whatever be the question, that represents P. So my question is exactly 4 will recover. So X is equal to 4. X is equal to number recover from the disease. X follows binomial with parameters N and P. And we remember the binomial distribution NCX P power X Q power N minus X. We need to find 4 will recover. So X is equal to 4. NCX 6 C 4. P power X 0.25 power X value 4. Q 0.75 whole power 6 minus 4. 6C4 meaning 6 into 5 into 4 into 3 by 1, 2, 3, 4. Or I can say 6C4 is nothing but 6C2. 0.25 power 4. Use your calculator. It is 0.00390,625. 0.75 power 6 minus 4 is 2. It is 0.5625. As we multiply and simplify, we arrive at 0.03295. So this is exactly 4 to recover. We'll take and write it in answer. Probability that 4 will recover out of 6 is nothing but 0.03295. Question number 3. If electricity power failures occur according to Poisson distribution with an average of 3 failures every 20 weeks, calculate the probability that there will not be more than one failure. The question is, will not be more than one failure during a particular week. Here it says 20 weeks, there happens 3 failures. So average we denote as lambda in Poisson distribution, which is 3 out of 20 weeks. If I simplify, it is 0.15. The question is, calculate the probability not more than one failure. So my question is, X is equal to number of failures. Given X is following Poisson with parameter lambda. We recall the formula for Poisson distribution, e power minus lambda, lambda power x by x factorial. Now my question is, not more than 1. So what does this mean? Not more than 1 tells me it is either equal to 0 or it is equal to 1. So not more than 1 tells me it is below or equal to 1. So I just add below or equal to 1 as 0 and 1. In the formula, wherever lambda comes, put 0.15. E power minus 0.15. 0.15 power x value 0 by 0 factorial. Again, e power minus 0.15 lambda power x. 0.15 power x value 1, denominator x factorial. As I simplify, in both the cases, e power minus 0.15 common. Any number power 0 is 1. 0 factorial is also 1. So 1 by 1, I just get 1. 0.15 power 1 is 0.15. 1 factorial is also 1. As we simplify, we just get e power minus 0.15 into 1.15. How to calculate e power minus 0.15 from the table. We check the exponential function table. My question is e power minus 0.15. So I check 0.15 under 0. The value 1.1618. As we had checked, e power 0.15 is 1.1618. How to calculate e power minus 0.15? Just reciprocate 1 by 1.1618. Use the calculator and divide to get the answer 0.8607. Let us substitute the value for e power minus 0.15 as 0.8607 into 1 plus 0.15 is 1.15. Just multiply and we get the answer 0.98981. So the question is probability of not more than one failure. And my answer 0.98981. Question number 4. Vehicles pass through a junction on a busy road at an average rate of 300 per hour. Find the probability that none tells me x is equal to 0 passes in a given minute. The question stated per hour but asked per minute. So let us change this for minute. What is the average rate given? It is 300 per hour, or 1 hour contains 60 minutes. So 300 divided by 60 per minute. Why do we convert for minute? The question is asked for minute only. So my answer is 5 and this I call lambda. How to calculate e power minus lambda? We will refer to the table. In exponential table, my question is 5. So check under 5 under 0. Under 5 under 0 my value is 148.413. As we refer to the table, we got 148.413 for e power 5. But I want e power minus 5. So it is 1 by 148.413 and the value is 0.0067. So whenever it is Poisson distribution, we need to calculate e power minus lambda to substitute in the distribution. So what is the distribution? E power minus lambda, lambda power x by x factorial. Now the question is, have they mentioned Poisson distribution anywhere in the question? No. Then how are we to identify? As I read the question, they have mentioned only average rate. So whenever average alone is mentioned, we can very well use Poisson distribution. As I recall the formula, which is e power minus lambda, lambda power x by x factorial. My question is none. So none tells me x is equal to 0. What is x actually? X represents vehicles passing. So x is equal to number of vehicles passing through in that particular unit of time. But the question is none, so x is equal to 0. E power minus lambda value 5. Lambda power x, 5 power 0, x factorial, 0 factorial. E power minus 5, as I have calculated, 0.0067. 5 power 0, 1. 0 factorial is also 1. So my answer is 0.0067. So probability that none vehicle passes through. we get 0.0067.